have this version, I believe.
Okay.
So if I can
Well, I
just
went ahead
send
and
that to
started
Bart.
recording. If you want to record it or say it, or just send it to Bart and he can
All right.
maybe
I'm gonna,
show it.
I'm gonna send it to Bart now, and then if you put it up, it's the header for the paper, and so if you, okay, I've just sent it. So if you want to put that paper up, you can use that one I just sent, please.
What are we doing here? What are we getting a disclaimer for? What's going on?
So we're going to talk about wall power. I don't want anybody to attempt this on their own. Well, I'll read the disclaimer. Why don't I do that?
Yeah, please.
If I may. So basically, at the top of the paper, and it includes this video advice today over Zoom. It says, please read this recommendation fully and then get an electrician to agree and do the work. If you decide to do this yourself, then decide if you have actually done this kind of house voltage electrical work before and are competent to do so and accept the risks of doing so. I am the national sales manager for MSB. They have nothing to do, the company has nothing to do with this advice. I have a separate company that's called Galbo Design. And so MSB, Galbo Design, Vincent Galbo, myself, we make no guarantee or accept any responsibility for any injury or the result of any damages caused by considering or performing the procedures outlined below. MSB, Galbo Design, or Vince Galbo make no guarantees the information is correct or complete. Rely on only the services of qualified personnel to interpret the information and perform it safely. The reader of this document is responsible to decide who's qualified to perform the work. The reader of this document is responsible to determine if any of these recommendations are in violation of local codes. There's a couple of other, I'm going to just call a couple of things from the the middle of the text because let's see here. If you decide to do this yourself, again, you're taking responsibility for your ability to do it and any injury involved. Do not be tempted to use your rubber-coated pliers, screwdrivers, those kinds of things. They are not rated for electrical. There's electrician's tools are rated for electrical and a certain voltage. That's about it. I mean, my message is clear that this should be done by an electrician and evaluated as such. All right, thank you. So,
Okay. Well, we can get rolling now. And thanks, Vince.
thank you.
I'm going to go ahead and share my thing maybe here, share screen, and start my little presentation. And per Vince's recommendation, I hired an electrician to run the 8 gauge and take care of all of that stuff. This is just a kind of like a diagram of the wire run. And you'll see starting at the bottom right. Can everyone see the screen?
Yes.
Yes.
Okay. From the breaker, I've got 8 gauge running.
Hey, Bart, if you hit play, I think it'll eliminate the menu on the left and make it a little bit bigger to play slideshow. Try that.
Where the hell's that at? I gotta find it first. I'm not.
To the right.
Slideshow. Here, maybe that'll work. Play from start.
Yeah.
Okay. Let's. Oh shit. Wait
Did
a
you
minute.
lose your comments though?
I did, and I've lost half the screen. So how the hell do I get back then?
Just hit escape.
Yeah, escape.
Try escape.
Yeah, there we go.
Okay.
Okay.
Never mind.
So anyway, starting from the bottom right, there's a breaker box, and there's 8 gauge running out of that about 45 feet. Now, it's 30 feet to the drop for the front end rack, okay? And that drops down at 10 gauge. I'll show you the pictures of that in the next slide. And then it continues for another roughly 15 feet where it's dropped down to 10 gauge and then passes through where the front wall is in 10 gauge to two outlets along that wall. So the next screen, number 2. And sorry, it's I couldn't get this thing to realign, but that's the drop. And you can see at the very right, which is the top, that's the outlet for the TV projector. That's a PS audio that's in wall conditioning. Then it goes down to I've got a few different brands here. That one's a $12 Hubble, the orange one. The next one down is a Furotech Rhodium. The next to the bottom is AudioQuest, and then the bottom one is MIT. We did a receptacle shootout at my house a few years back with John Shea, Charles Hurt, and I think it was AJ. And it was an interesting thing. And we did that as a blind thing. It wasn't double.
It was Rick. It was Rick. It wasn't AJ. AJ wouldn't do anything.
All right. Well, there you go. So anyway, you can see my beautiful wiring job there. This is the front wall. And about 2 feet up along that board, you can see the orange wire, just barely. It's not a great picture, but that kind of shows where the there's one drop to the left, and then there's another one to the right. Here's a close-up, sort of the one to the right. So that's the 10 gauge, and if you look just to the left where it's dangling down, you can see a original power outlet there. That's a 12 gauge, just a normal circuit.
Is a normal circuit a 14 gauge or a 12 gauge?
That's 12 gauge. 12 gauge
15 amp
household.
is typically 14 gauge,
Right, yeah.
right?
It is 12 gauge. I did look at it because I was playing with the stuff and rewiring some of that as well.
Okay.
That's the rack. It's done. It's basically like at the old house. And there's the new front wall. And so behind the trios, there's both a duplex outlet of the 10 gauge that started out as 8, and also the original household. And I had it all set up and was listening to the original wiring, and I did that for about a month before I actually got everything connected and was ready to use the 8/10 gauge. And one evening I switched over to the new, and I was really shocked. It was quieter, and you kind of expect it seemed to have more slam, better transient response, but it really improved in every way. The audiophile terms, clarity, imagery, naturalness, all big steps up really. But the biggest surprise that I had was listening to the first 2 recordings I put on. I'm really quite familiar with, and I heard stuff I'd never heard before in there, subtle nuances. And later on, a couple of days ago, actually, I was listening to Foreplay, and Ballet Run is one of my favorite songs they do. I've listened to it many times over several years. And I heard a little horn arrangement toward the end in the background that I've never heard before. So it's, to me, I'm delighted with it, and I'm really grateful for Vince, sharing this information. And I'm glad I did it. I was rewiring the house. I knocked down walls, was doing new ceilings and stuff, so it wasn't a big issue for me. And the price of one and run 8 gauge, or like I had at the old house, 3 dedicated lines, I believe it was cheaper just running the 1/8. And the results I'm tickled with. So with that, I would like to pass it over to Vince and let him give some explanation as to why it works.
Okay, thank you. And thank you for putting the effort into that and the faith. I think we were on the phone earlier, and I said that people tend to, it's exciting to upgrade your system. What's exciting is ordering a new pair of speakers or a new amp or new whatever, and then, you know, opening the box, and there's excitement. And that's part of the fun of the hobby, is the hunt. Breaking out drywall, hiring an electrician, doing all these strange things. A lot of people go, nah, not me. I'm not doing it. So this has been a 20-year sell, but the people that have done it, I can't think of anyone that hasn't responded like Bart has. So the question is, what's the goal, and why does it work? So I can go on, by the way, but I'll try to keep it short. So this is the power. This is, we know that the power looks like this is a picture of it, and then this is positive. This is this cycle, this period here from here to here is 1/60th of a second, so it's 60 times per second. We get one full positive and a negative, and then it repeats. And this from here to here, this is 60 volts, and then from here to here, this is 60 volts, and if we go peak to peak, it's 120. So that's how that works. Yeah, and pardon me if I'm oversimplifying for those of you that know.
Let me interrupt for a moment. If everybody goes to speaker view, he'll be big screen. You'll be able to see his drawings clearer. Thanks, Vince.
Okay, thank you. So, and I'll tip this a little bit. So, so what's going on here? So, the point is that the breaker panel for my screen went blank for whatever reason.
You're back.
Everyone's got to mute. Everyone should mute while he's talking. So, because if you cough, it's going to show you.
Right, right.
Oh, I see. Gotcha. So anyway, the breaker panel for our purposes is what we would technically call a zero source impedance. All that simply means is that for as fast as we want electricity, especially the speed, and as deep as we want it, it's unlimited for our purposes. And the other analogy I use sometimes is if we take some AA batteries and we stack them up and make 12 volts and try to start our car with it, it ain't happening. So we need a robust, fast output. So that's what the breaker panel represents for us. Now, if we put I'd like to use extreme examples to get the concept. So if we took a big amplifier and we put it on a 100-foot extension cord, 14 gauge, and then you took a picture of the electricity, and this is a picture of the pure power. What's happening is, because of the resistance of this long wire, this long skinny wire, when the amplifier is modulating the music up and down, it's also modulating the power. That effort has to come from somewhere. So at the long end of this light gauge extension cord in this example, if we were to put a scope at the outlet, we would see the music impressed on this, riding on this line. If it was bad enough, we might even see this truncated, like shortened, because we're not getting enough power. And the reason that happens is, if you've ever seen the inside of a big amplifier, you'll see capacitors in there. And the capacitor is like a battery that can go dead and charge up thousands of times per second. So we use that to smooth, we use that to smooth the power out. And I'm just drawing this as sort of an empty tank, full tank. So the capacitor's full, and let's say that we've got, this is not power now I'm drawing, let's say that we got a music bass peak. So as the audio section of the amplifier starts to use this power, the capacitor's full, it'll pull the, we'll call this full at the top, and here's a 3/4 tank and half tank and quarter tank. We would see this moving up and down, supplying the moment-to-moment power because we're working at frequencies that are 100 hertz, 200 hertz and up. And so it's modulating the capacitor, and the capacitor can only refill every 1/60th of a second in this time period. So we need the capacitor to sort of buffer in between. Now, as the capacitor is getting pulled down, let's say it gets pulled down deep, it's important that it gets to refill quickly. The ability of it to refill quickly is really sort of slave to the resistance in this long extension cord that we have. So if we've got a lot of resistance between the breaker panel and the amplifier power supply, this is going to come up slow. If we've got very low resistance, it's going to come up fast. And the higher we can keep this topped up, the better the moment-to-moment power is for the amplifier section. And because as it sort of tees in, like here's the power from the wall, and here's the power going to the audio circuit. So as the audio circuit is pulling down this power, it's flowing this way, but as this gets lower and lower, it starts to flow this way. So it's important that we feed the capacitors and the power supply. Now, the other thing to know is that every octave down in audio requires twice the power to keep the same flat frequency response. So we all know that our goal is flat frequency response. If this is 20 hertz and this is 20 kilohertz, and we want that to be completely flat. So we can make a test tone that puts in all frequencies, and we want this to be perfectly flat. And then I'm going to do a vertical scale. So if this is 20 kilohertz, and this is 10, and this is 5, and this is 2500, and this is 1250 on down. Each one of these is an octave. Each one is half. So if we're playing, I don't know, say 2 watts into the tweeter, and we put in this test tone that's completely flat, we're going to be, it's 2 watts into the tweeter at 20 kilohertz, we're going to be pulling 4 watts at 10. We're going to be pulling 8 watts at 5. We're going to be pulling 6 watts at, or 16 watts at 2500. And we're going to be pulling 32 watts at 1250. By the time you get down to 20 hertz, we need 1500, 2000 watts, which is why subwoofer amplifiers are so powerful, to keep things flat. So the important thing, and this is the reason to talk about this, is like Bart said, and my initial intuition when I first did this, I had a pair of Martin Logans, and I loved the detail, but I had no bass, I had no drum hits, and I had a big Krell amplifier. I said, I'm going to put in 10 gauge line. I was only at 20 feet, and I said, I'm going to get that bass back. And I put that 10 gauge line in, and I did everything that's in the paper, the silver paste and all of that. And I didn't get any more bass at all. What surprised me was exactly what Bart said: the clarity, the detail, the the truth and the overtones of the instruments, the human voices. Every way, and as Bart said, every way that you could talk about audio got better. So I started to reverse engineer why this was going on, and so what's happening is that at the bass frequencies, and we've got this long resistance from the breaker panel out to the amplifier at the bass frequencies, it's modulating the power up and down. My drawing blew away. But you get this noise sort of riding on the power, and it's noise. It is the music, but it's noise for the rest of the system. If the DAC sees it, the preamp sees it, it doesn't know this modulation that the amplifier is creating from noise, and then the amplifier it's starving for power for the moment-to-moment ability to refill these capacitors. So the bass frequencies modulate the power, affecting the mids and upper frequencies. So as I said earlier, if if we put a scope at the end of this long extension cord, we're going to see this noise. If we could keep that long extension cord and we went back to the breaker panel and measure on that circuit breaker, we would see the pure power. We wouldn't see the noise. So the way to get this to stop, it's the simple goal of this paper is to use big fat wire. And there's a point where, you know, you question, well, more is better. I did modify the paper about 5 years ago because I had it, I think it was 10 gauge up to 50 feet, but I've since have modified it 10 gauge, you know, and as little as 10 feet. It makes a huge difference. But you really got to jump to 8 gauge. I don't know. I think I have it after 30 feet. It seems excessive, but it absolutely is audible. And then I think after 60 feet, I have 6 gauge. And at some point, if you're at 80 feet, you can choose to run, you know, separate home runs at 6 gauge. You might start thinking about a sub panel. I don't think I have a preference. But it's also nice to have separate circuits because the subwoofer probably is the worst criminal in the system. The amplifier is a close second. And then the other things in the system are victims of that modulated noise caused by the amplifier and the subwoofer. So, that's basically it. The thing that I've added recently is twisting the Romex, all of the feeds. If you're running in conduit and you're running separate power and you know, line and neutral, you twist the black and the white. I don't think that's in the paper yet. It's due for an update along with some power conditioning things that have come to light. So you twist the heavy current carrying wires. In that case are the black, which is line, and neutral is the white. And you twist those. You keep the ground out of that twist. If you're using Romex, which is perfectly fine, you twist the Romex. This makes the electricians crazy. You don't have to do this. I never do this. I never have a problem. You know, the electricians are funny about it. Some of them are interested. Some of them refuse. Some of them say it's not code. I have yet to, you know, when I press someone and I say, well, you can, if I use too light of a gauge of wire for a certain amp rating, yes. But if I use heavier, show me in the code where that is not allowed. So I haven't seen it. Again, as per the disclaimer, everyone should check their codes against what I'm saying and recommending. So that's basically it. It's heavier gauge wire. Oh, and I didn't finish explaining. So on the twisted wire, the reason for that is, so this is it's an interesting effect. So how I think of it is this: Faraday, back when he was in the 1700s experimenting with magnetism and electricity, and he discovered that there was a magnetic, I call it a cylinder around a wire carrying current. And the way I like to think about that is if, you know, you might have had a horseshoe magnet when you were a kid, and they came with a little shorting thing that you put on it. So when the shorting thing is off, there's a definite north and south. When the shorting bar is on there, there's no endpoint, and there is no north and south, but it has a bias. It's not spinning. Often in illustrations, you'll see a wire saying there's a right-hand rule. I forget if the current's going this way, you know, and I can't tell you exactly what it is, but you can find it online if you're interested. But the point is that the magnetic loop has a bias left or a bias right. It's not spinning, but it's, you know, it's sort of a hard concept for me anyway. Okay, so if we think about AC, we've got 1/60th, 120th of a second. We've got positive, so the magnetism around the wire is, you know, let's say clockwise. And then when it flips to negative, it's counterclockwise. So it's constantly, the magnetic field around the wire is constantly collapsing to zero and expanding, collapsing to zero and expanding, doing that. If we have two wires in shotgun configuration, they are able to induce other wires near them. The other thing that can happen is they're able to be induced. So if you've got, you know, a cell tower, TV station, all that stuff. They can induce that wire. So a very common practice is what's called common mode rejection. We take the two wires, you know, everything has two poles. So in our case, it's the black line and the white neutral. And if we twist them, they become incoherent in both directions. They cannot emit a field and they cannot absorb a field. And a very common example of this is like a Cat6 cable. If you take one apart, it's got 4 twisted pairs. They're able to run megahertz frequencies through them, and there's no shielding. And they get away with that. And in fact, the twisted pairs are twisted at slightly different rates, so the nodes don't line up, the twists don't line up and talk to each other. So those wires exist very individually electrically, but they can run like right on top of each other. So that's the idea with twisting our power. So it rejects, there's 2 things. It rejects, you know, just airborne noise from anywhere, your Wi-Fi, cell towers, microwave relay stations, all these things that are bombarding the air. And the other thing is that at the high power of 60 hertz, these wires don't emit. So you can run them, I say keep them 6 inches apart if you're running separate circuits, and they will not talk to each other if they're twisted. And there's no magic to the twist. Just, I say if they're running next to each other, twist them slightly different rates. You know, it's twice per foot or 1.5 times per foot. It's not real critical. So that's it. The heavier gauge wire, I had a friend who is probably as methodical and curious as engineer as anyone I know. So he saw my paper and he actually did tests on a circuit with his big Griffin amplifiers. And he started with 12 gauge and he went down to 10 and he went down to 8 and he went to 6, he went to 4, he went to 2 and he went to 1/0. And he kept measuring. This guy does a spreadsheet when he brushes his teeth, and I tease him constantly. He got measurable resistance down to is the fattest wire he could put on, or not measurable, but measurable reduction in the modulated noise down to, you know, like welding cable he had. And I say that there's some point where there's a threshold where it, you know, it doesn't matter anymore. It doesn't affect our purposes. So had Bart put in, you know, 2/0 or something like that, I don't think he'd hear it. Unfortunately, 12 gauge is, it's like 1 gauge short for, you know, most audio rooms. It's a shame, but you know, who knew? But the good news is we can fix it. So I think I've explained everything that I want to talk about. If anyone has any questions or.
I have a
Is
question.
there, do you, I'm sorry, go ahead, Ronnie.
Yeah, I was reading your paper and you were talking about, you know, using isolated grounds and running ground wire to outside to 3 ground rods, tying the ground rods together. And at one time, about 5 or 6 years ago, I did that with my ground, with an isolated ground, run a ground wire outside, but used just 1 ground rod. And, you know, with the 1 ground rod for the ground, I didn't hear any difference. But about that time, I was talking to a fellow that was from Dallas, or just north of Dallas. He was an electrician. And he said he did the same thing. And what happened to him is lightning actually hit that ground rod, sent fire back into his house, caught his drapes on fire. And so at that, right after that, I disconnected my ground rod and pulled the wire back in the house. But that's just something that can happen. Another thing I wanted to know is, you know, you say, you know, run, you know, 8 gauge for most systems, but at how many amps? And some of our systems pull a lot more amps than others. You know, if you have, like you say, a big Griffin transistor amplifier, it's going to pull a tremendous amount more amperage than a little 8-watt amplifier that I use, like for my my highly efficient speakers. So, I mean, is there any point where you can get away with, if you have a smaller system with not running the 8 gauge?
Well, yeah, I don't, 8 gauge is not the starting gauge. That's what Bart did because he was over, how many feet, Bart? I forgot.
I'm, let's see,
45 feet?
yeah, 45 feet is my total run.
Yeah, so I think in the paper I say it's over 25 feet, then you jump to 8 gauge. But below that, 10 gauge I think is sufficient. And you're right, there's some relativity to the wattage of the amplifier, and actually the VA or the volt amp of the transformer in the power supply of your amplifier. So, and I say you can always weigh that by the pound. So, you know, worst case is, you know, 100-pound power supply, really inefficient speakers, a big room. Every time we double the cubic volume of the room, the power required for the same loudness is 4 times. It's like one of the laws of energies. It's a square law. So that's worst case. And you're right to question continuous power, which is what we tend to do with electricity. But even your, what do you got, an 8-watt amp?
Well, that's one of them. I mean, I have others. I have an 8-watt amp in my in my amplifiers, and then also there's another plank amp on my subwoofer, which that's different. I don't know the exact amperage it pulls, but it doesn't pull a lot for a subwoofer. Well, it's actually a bass cabinet. Then I have another subwoofer I run when I play classical music, and that pulls more power than the
Yeah.
either. Actually, there's 3 amplifiers.
Okay, so are they all on the same circuit?
Now they are, yeah.
Yeah.
What
So
I,
that, so we have to, as I tend to say, it's the worst criminal in the system. So the subwoofers, it's not the continuous, and this is a rightful way to look at this as the continuous. But with music, as I was saying, on this scale of power, you know, every octave down, when those subwoofers kick in, if you'd had a good high quality recording oscilloscope, you might be hitting 300-watt peaks on those subs. We're talking, you know, milliseconds. But that's the very thing that's pulling power down for the moment and slowing the recharge of the capacitors in your 8-watt amplifier. So this isn't about continuous power draw. It's moment-to-moment power draw, and the way to make it absolute, so there's no you know, compromise in that moment-to-moment, is just fatter wire. I predict if you do this, you'd be very surprised. And if you've got, you know, you've got a tube amps, they tend to have nice clarity. You've got you know, a good system, good speakers, and all of that. You'll hear this. You know, some people rave more than others. Everybody says there's a positive benefit, and we've all got systems of different resolution. In the company I work for, I've sort of coined the term, everybody's got their best experience so far. So I've walked into systems I thought were, you know, not so good, and people are thrilled with them because that's the best they've heard. And certainly I've heard systems that are amazing for all the things we value. And those systems tend to show bigger differences when we do things like this. You know, this very fundamental resistance back to the breaker panel, you know, power cords, interconnects, all those things. They scale, the differences between them scale bigger the better the system is toward, you know, live music. So, but it's not, you know, I sort of ask people to get the continuous power concept out of their heads and think about more of the, you know, how fast and how deep can I get the current? And the only way to do that is with fatter wire. And we consider the breaker panel, again, to be infinitely sufficient in all ways, you know, speed and current.
were you saying that if you ran like say 3 or 4 different circuits, that they should all be individually run back to the panel then if they're separate circuits, right?
Yeah, the beauty of that is, as I said, we really can't modulate the utility. We've got big fat wire going out to the transformer outside our house. So again, we're not, this is a local problem within the house. And the other thing with separate circuits is even after you run this heavier gauge wire, the amplifier is still modulating that line a little bit. So if you have one outlet and you plug the DAC into it and you plug the preamp into it and the phono preamp and all that, they're still seeing a copy of that. The way to make it absolutely isolated, and I sort of alluded to before that the biggest criminals are usually subwoofer, the amplifier is closely related, and then the other things in the system are victims if they're all on the same circuit. So by separating them, let the amplifier, now that we've got heavier wire going to it and it's sufficiently moment to moment getting the speed and the current it needs, let it be by itself. Same with the subs. Separate the subs from the amplifiers, and then one line for your front end. And it's nice that that's 10 gauge. We're not, you know, pulling a whole lot of continuous current there. The peak to peak, you know, peak current moment to moment, again, which is the goal. Much less for that front end stuff, but it's still nice to run 10 gauge, just, you know, to say we've upgraded. And following those concepts, it's pretty shocking. It's surprising. I wrote this paper 20 years ago when I used to have the Plinius line of amplifiers, and they made some pretty good size amplifiers. They're smaller. Class A amp was 90 pounds. And I took it from my house with my system that was very good and took it to the New York Audio Show. And it was disgusting. I mean, I couldn't believe how bad it was. So I was already sort of onto this, this idea behind this paper. Of course, there's no way to fix that at a show. But it is possible in situations, and I do this at shows now, where you can't do anything about the wall wiring. This noise that I described earlier that rides on the line, you can quiet that through certain filtering. And this is another completely different discussion, completely different category. But, you know, power conditioners, why do they work and what do they do? So it's possible to filter that noise and subdue it. So I went and got, there wasn't a whole lot of stuff available at the time. This is 20 years ago, but I went and got 3 Richard Gray power conditioners. And I liked the idea. And anyway, I put them together in the same outlet, and it completely fixed it. It just, it sounded like I did at home, and like it did at home. And I, you know, it was another data point in sort of figuring out what was going on with this stuff. While I'm thinking of it, if you've all got your pen out, there's a meter that you can buy from Alpha Labs, and it's called the Alpha Labs Power Line Meter, and it's $130. You can get it on Amazon or anywhere. I like buying it directly from the company. It's a little company. It's Scientific Instruments. And you can check, you know, how your system sounds better at night sometimes, and you can sort of, it's not the be all and end all, but it's a good indication of what your power quality is. It's important to note that these modifications we're talking about with the heavier wire do not affect these readings. And you plug this meter in the wall and it gives you a readout in millivolts of noise from 10 kilohertz up to 10 megahertz. So it's this high frequency noise that's in most systems. And I have seen the meter tops out around 2000 millivolts, which is 2 volts of noise, which is very high. And that's not uncommon. At our own factory at MSB, we've got, you know, industrial power. It's terrible there. I've had some dealers, especially California seems to be really bad there. I had a couple customers that, you know, again, if 2000 is the top of the scale, and you can have more than that, the meter just won't read it. I had one customer say, well, you know, the system sounds great with your DAC, and I'm really happy, but tell me about power conditioners and power cords. People are always trying to sell me stuff. It always sounds worse or makes no difference. So I sent him the meter, and he had 40 millivolts, which is like nothing. And I said, go, turn the microwave on. Just tell me what you see. And he got a slight rise. And check it day and night. And he's never over 60 millivolts. It was beyond my belief. And then my granddaughter just showed up. I got another guy in Colorado, same thing. He bought a meter and he checked it and he's like below 70. So they don't get any benefit from power conditioners. But most of us are going to be in the 400 to 800 range. There are certain things in the house that are incredibly noisy. If you've got a lot of LEDs, depending on the dimmer type, they can be noisy. The other thing we found to be incredibly noisy, if anybody's got any of these wall-mounted air conditioning units that are split systems, they're just terrible for this. So these are the things that a power conditioner can improve. And the design of power conditioners are all over the map. I actually carry around to the shows 5 different brands, and sometimes my go-to one that works at most shows might not work at a show, and I've got to go to the one that didn't work as well at the last show. So it's the characteristic of, where is the noise in the spectrum? Is it down low? Is it up high? Is it broadband? Is it spiky all over the place? So we're sort of, we got an ongoing study about why some power conditioners work better than others. The people that make power conditioners would profess to say that, well, our power conditioner covers everything. Well, they don't. I'm looking for the one that does, and it may be out there. I just haven't tried it yet. So that's just a little side note about power conditioners. But this meter is very useful for $130. And if you get a reading, check it that night. And you got any questions about your readings, I'm glad to talk about that.
What was the model number of that again?
It's just called the Alpha Labs Power Line Meter. If you Google it, it comes right up. And I buy it from the company.
I've got a question. First of all, excellent presentation. Has really opened up a lot of thought for me. I'm curious, has your paper or similar paper ever been presented to AES? Is there any scientific assessment of these principles anywhere?
None, zero. It's just a wild claim at this point. So.
Also, what about a power regenerator versus a power conditioner? Would that potentially have better impact in this regard?
It's a good question. It's a great idea. My feeling about that is it's also like isolation transformers. So you say, well, I've got a big solid state amp, and the size of the transformer in that amplifier is 2000 VA. So all transformers that deal with power are rated in VA, volt amps. We don't need to know about that other than it's just a relative rating. So let's say that the amplifier has a big transformer in it, and it's a 2000 VA transformer. The question then is, if we use an isolation transformer, and this will go to your question, if we use an isolation transformer, how much bigger does that transformer have to be than the amplifier transformer to look like the breaker panel's zero source impedance? Just infinitely fast for our purposes, infinitely deep for our purposes. I think the numbers are scary. What I have done for some customers with really difficult power, including a dealer. I've got one at a major speaker manufacturer. We went there and the sound wasn't good. We put our equipment in and it was better. I said, we're really suffering here. And I did the measurements with the meter and they were horrendous. And it's, by the way, toroid transformers, and I don't want to mention brands, but anything that's a donut-shaped transformer, terrible idea for isolation because they are bidirectional for noise. So we use bobbin core or EI core from a company called Controlled Power. They're 400 pounds. They go outside behind a bush. It's serious, but in the worst cases, these have worked tremendously. And even then, you get very high frequency sort of passing through everything because it floats around, and then you can put a small power conditioner in as touch up. And we had remarkable results at, you know, the speaker manufacturer, our own lab, a dealer that had good sound, but, you know, was always unhappy with it. And the day that he hooked it up, he called me up and he said, you know, why doesn't everybody know about this? Of course, their measurement on that meter was terrible. So the same thing goes to regenerators. It's a great idea, except I think it has to be the size of a Volkswagen to run a good heavy solid state amp. So, you know, I had a PS Audio, a P10. It was good. It did well. I said there's times when it was a little unstable at times, and there's times when I felt like it was struggling for current. And when they came out with the P20, I wasn't surprised at that. And I don't know that it's big enough for anything but a small amp. It could be. I haven't played with it, you know. But again, it's as far as a pure, you know, pure power. And so the problem, if it's not big enough, then your amplifier is now modulating this regenerator. So you end up with the same thing. It's resistance in the path back to the breaker panel.
So does going to, sorry, I didn't mean to interrupt. So going to a larger gauge power line, does it make a bigger difference if you're using, say, a 16-watt tube amp versus two 600-watt mono amps?
I think you're absolutely right about that. We sort of alluded to that earlier. So what does that mean? Are we going to spend a little less money on copper and do the lighter gauge version because of our amplifier today? And then, you know, I don't know the scale of that. The theory holds, and you're right. In the case of the 8-watt tube amp, but you know, people have done this with as little as 10 feet from the breaker panel. Go to 10 gauge with, you know, fairly low watt amps, small solid state amps, and say, you know, it absolutely is incredible. So I haven't talked to anyone that had a null result, said I did it and I don't hear anything. And I wrote this paper in its first version, you know, 20 years ago when I had, you know, this the Plinius line of amplifiers. So and I've, you know, updated it a few times since, but nothing's changed as far as the goal. It's always fatter wire. And the questions like this, you say, well, geez, it's hard for me because my house is on a slab. I can't get through the attic, you know, whatever the difficulty is. So I say, you know what, go buy the wire, go buy the Romex, buy the length that you need, get to have the electrician do this, get a metal utility box if he's willing to do it, and hook it into the breaker panel. And I had a doctor in Ohio do this. He ran 80 feet of 8 gauge. And then you jump down to 10 gauge at some point close to the outlet. And just, you know, run it across the couch and through the kitchen, wherever you got to go, and plug the system in and push play and see if you say, you know, this is worth it or it isn't. You know, I think I know the answer, but I like for people to discover things on their own.
You have any experience with the APC S20 BLK?
What is that?
APC power conditioner.
I don't.
Okay, because I had a professional noise meter on the line coming out, and it was like 232, and the output of the AP, and it had all kinds of modulated radio signals. You could hear a radio station on it, and it was like, it sounded like that. The output of the APC was 0.00 and no noise whatsoever.
Yeah.
Well, Jeff, it's a battery backup with the line regenerator.
Yeah.
Yeah. So that's it's a good point. So this meter, if you put in a power conditioner and let's say you've got a reading of 700 and it reduces it down to 100, you say, wow, you know, that's great. So then you keep chasing that number. The problem is that the very power conditioners itself, like the APC, if it's a battery regenerator, does not have the low source impedance of the breaker panel. This is what we're competing with. So it's very easy to overtreat and end up with the sort of the same effect as our 100-watt 14-gauge extension cord in my first example. Power conditioners can get in the way of this. You get a low noise rating, but you've lost your ability to refill the capacitor in the amplifier. And this is apparently critical. And it's two different categories. It's you know, refilling the capacitor in the amplifier hooked up with low resistance to the breaker panel. That's very different than the noise coming in from the utility. So if we want to filter that, we've got to be careful not to over filter. And, you know, you could turn it into a endless science project, but my point is that once you've got your heavy gauge lines in, just go by ear. You know, you ought to hear it in 10 seconds.
Hey Jeff, we should talk, because I've got the same conditioner you do, and I've done some pretty serious upgrades to that, including changing the wire size internally, and the results are very audible.
Well, how can you get less than 0.00?
No, that's not the problem. As he explained, the problem is what's called technically the insertion loss in the line between the amplifier and the panel.
It's a good way to say it. Yeah.
Yeah,
Okay, I don't hear any lessening of instantaneous dynamics at all.
How much do you spend on power cords?
Who are you asking?
I'm asking Jeff.
Not that much, because I used to have some very, expensive one. Well, not that expensive, but, the fire hose stuff. And then I replaced it with the stock cords, with the vac amps, with the stock cord. There was no difference. The APC made the biggest change, and it was dead quiet. Ask Colin. He was just over a couple days ago. Ask him how it sounds.
Yeah. So, when we're comparing notes like this and successes and questioning what someone's saying, what I say about it is they're all right. So in your case, you might have had horrendous high frequency noise, and the APC did real well at that. And your amplifier demand isn't quite as much as, say, a bigger amplifier. Your distance to the breaker panel isn't as far as someone else. So it's all variable results. So the theory is important, but as I say, fundamentally, if we've got the heavier gauge wire in place, we can now make better decisions about power conditioners relative to the size of our system, to what degree they're making a difference. And when someone makes a claim like you just did about the APC, I absolutely believe you. But as I said, the severity of the utility noise, it's all over the map. And even the characteristic of it, not just the severity of it, but the characteristic of it. If you've got, as I alluded to earlier, you got very bad, very high frequency noise. Is it broad spectrum? Is it down low in the spectrum? Is it changing day to night? And then what is the most effective power conditioner for your particular problem? And then does it have, and it said very well, insertion loss, meaning that we now are decoupled from the power from the breaker panel with its zero source impedance to some degree, that it's now affecting our result.
Hey, John Chait, you have good experience with running some high gauge wire?
Oh yeah, I did it about a year ago. I followed Vince's paper that he wrote for MSB, which is fantastic, and thank you for your presentation today. It's really, really good, and it just kind of repeats what's in your paper, and I loved it. But I went from downstairs to upstairs, and downstairs I thought I had it beat. I was running 12 gauge wire, 20 amp fuse, and I split it at the end and ran it to 2 outlets. So everything was being plugged into a power conditioner. All my amplifiers were being plugged into power conditioners because I only had 2 outlets. And then, the plan was to move upstairs. And so I kind of got ready for that. And I got my electrician, and I got my AC guy that installs installs AC vents up in the attic, so I knew he didn't mind the heat. So he ran the wire, and the electrician, all he had to do was hook it up. So they really gave me a good price on it. But in my system especially, I think I needed it because I have an all-active system, and I'm running 10 amplifiers.
Whoa.
And behind my couch, just behind my couch, it's 5,000 watts. So if anyone ever needed to do this, I think I did. So what I did is I ran a box up to the room and ran from the box 10 breakers, 10 separate different breakers to each outlet. I used the Hubble outlets, which are kind of bang for the buck, and they're really good. And I would never plug, after listening to the system, I would never plug my amplifier into anything else but the wall. I would never, ever plug it into a power conditioner, just because, kind of like what Bart was saying earlier, I experienced. And the dynamics and the effortlessness for me, and just the clarity, it's absolutely amazing. Probably maybe the best thing I've ever done to my system as far as making a change in it.
What was the gauge of the wire from the main breaker up?
I went 2 gauge up to the box, and then I went 10 gauge to each outlet, and then I kept the grounds the same length, which I think in the article, it does say that in the MSB article. I went by the MSB article, and it said keep the grounds the same length. So now I have basically, I have 6 outlets up front, and 1 is for digital, and all my digital gear, my preamp, my amp, my crossover, everything is plugged into power conditioners. I have a high fidelity cable power conditioner. I have an old Chang power conditioner, and I use those. But all my amplifiers are going directly into the wall with large gauge cable into the wall. So I went from 2 gauge, and then the box I went to 10 gauge because everything was under 30 feet. So that's how we did it.
Hey, John, rather, there's a question for all of us in Florida, of course. We have to deal with lightning and surge protection. So if you're plugging your amp directly into the wall, you've got to be concerned about the risk there. How are you dealing with that?
I got the surge protection. FPL offered the surge protection on my house. Now, could something happen still? Of course. I mean, if lightning hits your house, we might be buying all new gear. I don't know, but
lightning hit my outlet in the garage, and it killed my car. I had a Chevy Volt, and I can attest that lightning's a problem.
Wow.
If anyone needed to do it Vince's way, I think I did, because I had 5,000 watts in the back, and then I have like 1,500 up front. So each amp has to plug into its own outlet with the correct cord. So then I went 10 gauge into each outlet, and then I kept all the grounds the same length.
Good. That was a good installation, and I'm happy to hear that you got great results. I wanted to just touch on the subject of when you do a sub panel. It says in the paper it's important to upsize that wire too, because there's some benefit with the separate lines. As I said, if we think about the subs and the amplifiers being the criminal in the system, then their ability to modulate is high, and we do benefit from them being on separate circuits. But in the case of the sub panel, we might be much closer now to the breaker panel with everything, and then the ability of the amplifier to sort of modulate that panel as a whole increases. So again, we reduce it by a big fat gauge wire going back from the breaker panel to the main panel. So, and you did that. So I'm glad to hear that.
Vince, let me ask you a question. If for like John's situation where he plugs amps into the wall, is there any way you would recommend some type of circuit breaker by his upstairs panel? Not Not a circuit breaker, but a disconnect switch. I mean, I'm sorry, a disconnect switch.
Other than, yeah, there's no crime in that, certainly. The benefit would be as if a storm was rolling in. I think, if that's where you're going with this.
Yeah.
Sure, why not? But lightning, even with that switch open, if it depends how much current from the lightning strike is getting through. It could behave like it's not even there. The best thing that I know, and I think John said he's got whole house. They're typically, I think Square D makes them, and they go right in the breaker panel of the main panel, and they're special MOVs. The problem with them, an MOV is that they're metal oxide varistors, and they go from line to neutral, line to ground, and neutral to ground. And what they do is the metal oxide varistor is an element that says, anything over 500 volts, I'm just going to close and I'm going to short it. So it tries to take all the current from the lightning and bring it together in this network and pull it to the ground and try to route it that way. So the problem with MOVs, if you get a hit and they burn out and they go open, you don't know that. So, but Square D has figured out something. I think they've got LEDs and they test the efficacy of the MOV once in a while. But I think that's the best way to do it, and certainly stick with a brand name. Since I know Square D has them. But and make sure you got good ground rods. As far as that case where the lightning hit the ground rod, I'd have to believe maybe was there a lightning rod hooked to that ground rod? I mean, why would it just look for that ground rod when it could hit? Because lightning is looking for Earth. It's really interesting. We were in Disney World one time, and we were walking toward the lobby of the hotel, and my sister-in-law is walking in front of me. And she's got very light blonde hair, and a layer of her blonde hair lifted up like this and went straight up over her head, and then another layer, and it started to like accelerate. And we had 18 people with us. I told everybody, run, so they started running. And they said, what was it? I said, I don't know. We were in a powerful electrostatic field. If that lightning bolt resolved, that we were near it, So of course it didn't, but it had the potential. I also had a lightning bolt in my yard that took out the transformer. It followed down the pole, burned the pole. It's a ton of current, and if it comes into the house, you hear stories. So, and what path it takes, it's just looking for the path of least resistance, including the air. All you can do is guide it, and those wires. Like even the wire to the ground rod it's not carrying that current. It's all the ionized air around that wire is probably carrying more current than the wire itself. So what we want to do when it hits is guide it somewhere rather than let it go where it wants.
The thing is, though, if suppose that would have happened to the fellow from Texas when he wasn't home to put out the fire, his house burned down, his insurance wouldn't pay him off. That's the problem there. It'd be a total loss.
Well, if everything was done to code, why wouldn't he get paid?
Well, that's not the code.
What isn't?
Running a ground wire to the outside of your house.
My paper might not be clear on that, but it has to go back to the utility ground. And if it doesn't say that, I got to change that.
Oh, okay. Well, what we did, me and the fellow from Texas, we just ran it directly from the outside of our audio room to a ground rod, and his caught on his house on fire. I didn't wait for mine to ever catch on fire. We do have a lot of lightning around here.
Yeah, Ronnie, I was looking at doing that, and code here in Pasco County is you can put in a secondary ground rod. I have one right next to my breaker box, and it specifies the distance and depth, but they have to be bonded together.
Yeah, what I did was just run it right outside of my audio room. You know,
Yeah, well, that would not be the code, so yeah, you would be in trouble.
right. Well, that's what I mean. If that guy's house would have burned down, his insurance company would have never paid him.
Yeah, well, he should know to do it to code.
And he was an electrician too.
Oh, that's not good.
I didn't think it was right either, but I thought, well, I'll take a chance, you know. It didn't help anyway.
You know, earlier Mikkel in the chat was asking about any electrician recommendations. Maybe we can ask around and find somebody that could cover both Sarasota, Hillsborough, Pinellas areas and give us kind of a group deal if a number of us want to address this in our homes. If
I'm
anybody
telling you,
has-
I agree with you, Alan, but the best way to do it is find someone that will run the wires and let the electrician just hook up, because that's the big thing that they will charge you an arm and a leg for.
Your air conditioning guy, maybe he'll do it.
So I've talked
I'd
to
have
a lot of, sorry, go ahead.
No, I would have to talk to him.
Yeah. I've talked to a lot of electricians over the years, and you know, they do what they do. And they're thinking, when they see the specs, they say, well, oh my God, you know, 6-gauge wire, 8-gauge wire. What kind of current are you pulling here? What is this equipment? And what is, and I've come to tell them two things. We're wiring like we're pulling 300 amps, and we're going to pull 8 amps. And our interest in all of this, get the resistance as low as possible. So if you talk in terms of resistance to them, most of them will do it. I've had a couple guys just say, nah, it's too weird, I'm not doing it. On the other end of the spectrum, I've had electricians say, oh, this is cool, this is interesting. So I'd like to know the outcome, you know, so what, you know, and he'll do it to spec. But most of them questioned it. But if you just say, look, we're not pulling hardly any power at all. We're wiring like we're going to pull a ton of power, and we're going to pull hardly any, but we're getting the resistance way down for our purposes. And then they go, okay, you know. So that's the most common response. But yeah, sometimes it takes a little begging.
Can I have some questions? Can you hear me well, by the way? Okay. I have a question. Number one, I have solar power panels in my house. Wonder if they affect anything. And I have like generator from DC to AC. Second question is, what about digital amplifiers, such as based on N-Core? They don't have any capacitors in power supplies.
No, so even more critical, or let's say just as critical, they don't have much of a capacitance bank, and what they do is they pull all their power from the wall. The digital amplifiers, what they do, like one example is, let's say that the amplifier wants to make a 60 volt. Let's choose a different voltage. Let's say they want a 40 volt DC rail, meaning that that's the main supply for the audio amplifier. So what they do is they will take the 120 volts from the wall, and the reason that they don't produce any heat is transistors are at their most efficient when they're on 100%, completely turned on, or completely turned off. Everywhere in between, they produce heat. So what they do is they take, and this is a rough example, there's more technology, but they will take the 120 volts coming in, and they will turn it on, and there's a rise time. So they turn it on, and it's climbing at this incredibly fast speed, up to 120 volts. And when it hits 40 volts, they shut it off, and then turn it back on again. So it's called pulse width modulation. So it's when the amplifier is drawing a lot of current for a bass hit, they'll turn it on for a longer time, and then when there isn't much going on, they'll turn it on for a very short time. So it's called pulse width modulation. So they're constantly turning the power on long enough to achieve the 40 volts. It might be longer for a bass attack. It might be shorter for for, you know, light duty, let's say. But to do that, the frequency, how often they do this is in the megahertz, millions of times per second. Now you got this oscillator that's making a ton of noise. They deal with that within the amplifier, so it doesn't affect the audio circuits, but it's modulating the line, the AC line. So it's putting noise on the AC line. They make effort inside these amplifiers to have as little effect on the AC line as possible. But again, this goes to our goal in the first place. You know, how fast can we get the current, and how deep can we get it? So these amplifiers will absolutely perform better for slightly different reasons with the same modifications.
And the question about the solar power panel.
So those are inverters. They take AC. It's not unlike an audio amplifier. You take a DC, and let's say you run an audio amplifier, and this is what the regenerators do. They take the AC from the wall, turn it into a big DC bank, and then they run a 60 hertz oscillator that outputs 60 hertz. So this is the case with the inverters. They take whatever the DC voltage is from the solar panel, and then there's an oscillator that oscillates it at 60 hertz. They, I believe, we've got some systems around the country where people can hear absolutely when the inverter turns on and off during the day. Some are better than others. It would be nice if they generated a very clean sine wave. I'm not convinced all of them do. And then the other thing is that when they're on and you're running on that, how stiff is it? How low is the impedance relative to the breaker panel? It might be like the regenerator example, that it's a big inverter, but it's not big enough to give us the speed and depth that we need for our audio systems. So, and then if we did have a problem with that, you could clean up any noise it generates with a power conditioner. And again, you got to judge these things by ear. It's not, it would be a deep science engineering project to try to figure this out empirically. Fortunately, you know, with our trained ears, we hear it in 10 seconds, like Bart did, like John did.
Colin, you have a question? You're muted.
You know, Bart has incredibly efficient speakers with those trios. What are they? 108, 109 decibels per watt per meter. So his sub cannot really be driving a lot of the low bass. But even with your calculation, his sub doesn't actually need a lot of power to drive those low octaves. How much difference can improving the wiring really make to something that's so enormously efficient?
Hey, Colin, let me address you with my subs. I've got 2 pair of subs. Each they're enclosed subs with 12-inch drivers. And each one of those has, I think it's 400 watt Class A amplifiers. They do draw some power, and they go up to over 200 hertz.
So yeah, I think the rest of the answer would be like this example where we said that, you know, as each octave down requires double the power, when you get into the bass region, we're in the, you know, thousands of watts to make it linear. And I think no matter the technology or the speaker efficiency, you've still got that scale of needing that short-term power moment to moment, which is, you know, again, fat wire. Now, you know, the example that I use is that we've got a recording and the microphone's close to the drum and the guy really whacks that drum, and you're listening along at an average level, and that drum is almost shockingly loud, and you say, wow, that sounds like a real drum hit. You know, if we don't have that short-term current, the drum hit's still there, we still hear it, it just doesn't quite have, it's not distorted, sounds fine, but it doesn't have the impact. And this is the dynamics that we talk about, which is a very general term, but I think this is a good example of a moment where you say this system really sounds lively and realistic, where if you don't have those sort of peak abilities, you go for, it seems like for me, and I think most of us, every song seems to have a right volume. So we turn it to that volume so it's convincing to some level. I feel like when you've got this sort of unlimited dynamics that you end up listening at lower volumes for sure.
Bart and I were talking the other day about what the real source is in an audio system. We always talk about that's the CD player, or it's the computer, it's the turntable. To me, the source is the electricity, because that happens even before everything. And I have really efficient speakers also. Mine aren't quite as efficient as Bart's, but I do have horn speakers. And those are about 98 dB, 1 watt, 1 meter. And it still made an absolute huge difference. Now, of course, I have subwoofers also, but with just the 98 dB 1 watt 1 meter speakers, it just made absolute huge difference. So I think that's the true source, is the electricity.
Well, it is, and a good way to think about that is, and this is interesting. I'm going to draw a transistor. And it could be the same for the tube. You still got the same 3 legs. And here's power in, and here's the load, meaning the audio output. And there's power across here. We could just for general concept, we call this positive or negative. So here comes the signal, and what's happening here at this junction in the transistor? It's like turning a faucet, high, low. It's modulating the flow through here. So here's the original signal. It's producing more or less current. So if we could look at it on a scope, we'd see, this is the signal. And then at the output here, we see a copy of it, more voltage. The original signal ends here. You never hear it again. It's gone. And what the transistor is doing is it's modulating the power supply to make a bigger copy of it. And there's several, 2, 3, 4 stages of this in an amplifier, which is the challenge of preamp and amplifier designers or tube designers, is to make this bigger copy identical to this. And the subtle ways that can be wrong are, we hear it in a heartbeat. So, but to your point, the power that's applied here, if it's not perfectly quiet, flat DC, the output, the result is likely to be slightly different in some way. And boy, can we hear it. Hello.
Go ahead, Colin.
So Bart, you looked at the Hubble outlet, electrical outlet. Which Hubble outlet was that?
I don't know.
I can get you the number on it. It's downstairs, but I use the Hubble outlets. I'll get you the number on it. I'll send it to you.
Okay, because I looked for it, and of course they have tons of outlets. But
yeah, they do. It's the one with the brass. It's all brass. There's some other ones, cheaper ones. I think these are like $25 a piece or so.
Is it the hospital grade? Is that their best outlet?
Well, that was my next question. Is it hospital grade? Is that what you were comparing? Was hospital grade?
No, this was not hospital grade, but this one was mentioned as one of the best sounding ones. So Bart and I kind of went back and forth with it, and I think we went with this one. I'll give you the number on it.
Yeah, actually, the guy from AudioQuest is the one that told us about it, recommended it.
Because they do have hospital grade outlets. I have put in hospital grade outlets, and it was one of the best bangs for the buck. But some of them, like Levitron, they're only like $6 for quote unquote, hospital grade. I don't know how good that is, but boy, does it ever make a difference.
One of the things hospital grade connotes is that the ground pin is not hooked to the metal tabs on the outlet itself. So it's totally isolated. And then what you do with that is up to you. And I don't know that that is, inherently better. But I would hope hospital grade means, heavier copper, maybe silver plating. Those things are useful. And as I say in the paper, there's companies selling cryogenically treated, I just don't know, I worry about that half-inch of copper making any difference as long as it's sufficiently thick and is plated sufficiently not to oxidize.
I have one question, I think for John. You said you put your amplifiers directly to the wall. Have you tried those things made by Shunyata Research? This one called Guardian Pro, but I think if they also have Hydra. They claim that they have some magnetic breaker, which helps you if you have power surge, but doesn't really restrict or doesn't have any electronic components to, to stop you from lightning strike, but it's just kind of mechanical magnetic thing, which would save your amplifiers, but not change power flow in any way.
So I think that's a magnetic switch is a good way to do it. There's a company called Carling that makes those. They respond by when the current gets high enough, a magnetism opens the breakers. A lot of breakers are thermal, bimetal, which means that the current's going through it's two kinds of metal plated together, and the hotter it gets, at some point it'll bend and open when it gets hot. I like those less because they have to be thin enough to get hot, and they could be, some percentage of our long skinny wire. So they offer a little resistance, but the magnetic breakers, they don't have to make any compromises in the current path as it flows through. So those are good. And then as far as, if I'm not sure if I understood the question, but I'll say that conditioner on the amplifier, it really depends. We're talking about, now that we've got our heavy gauge wire, and how much noise are we getting from the utility? Is it very high? Is it not very high? And then does the power conditioner in any way sort of get in the way of our low impedance path? So those are all high variables. From, you might have great results with that conditioner, and somebody else will use it and say, no, it's, made it worse, or it's, I didn't hear any change, or, so all those things are possible. And I always, at the end of all these things, I say, use your ear. You'll hear it heartbeat. This includes power conditioners, power cords. But if one of your big choke points is a long path with skinny wire, all of this stuff is then sort of down in the mud, and you can't really hear the benefits of power conditioners as well as you could with correct wiring.
Do you mind if I share the screen? Because I think I found the one I'm using, if you don't mind if I share the screen.
Please.
Go for it.
Can you see it? Can everyone see that?
Industrial grade, great.
Yes.
Let's see it.
And it's $32. It used to be about 25, so it went up. But that's the one that's the one we did the shootout, and that Hubble, that outlet did really well in the shootout, if you remember, Bart.
It did. Actually, that shootout, the summary I did of that is posted. Alan posted that on our meetup. I think we all placed that at the end of the day, like at number 2.
Yeah, that's right. It was number 2. Yeah,
John,
definitely.
what gauge wire does that outlet accept?
10.
10, it goes up to 10?
Yeah, it'll accept 10.
Yeah, I've never seen outlets that don't accept 10. They all do, as far as I know. And while we're on that subject, if you're running 8 or 6, people worry about the connection, and you just put it in a metal box. Use wire nuts. In the paper, there's the silver paste compound. Circuit Works makes a copper paste. Just put something on there before you put the wire nut on to improve the connection. And that connection sort of ceases to exist as a connection when you put a little bit of that compound on. And so there's zero concerns. You know, we're audiophiles, we worry about every little detail, but to that connection should not be of any concern to anyone. It's the far bigger thing is the fat wire over the distance.
Yeah, I got a question about the Hubble. Is that an isolated ground outlet?
I don't know. I'll send you the link to it, Phil. I don't know. But all I can tell you is that's the one that AudioQuest recommended. That's the one we did the shootout with. So that's what I chose.
An isolated ground outlet does not make a connection between the mounting bracket and the ground pin. So if you have metal conduit in your house and things like that, or some sort of metal plate that conducts between the ground and the plate, the isolated outlets are the way to go. And I suspect that maybe that's what you found.
Hubble, you know, isolated ground industrial receptacles are orange colored. They're not white, they're orange.
Well, not all isolated ground outlets are truly isolated ground either. The mounting brackets are not always isolated.
I've got a question, Vince. I presume that all these different gauge wires you're speaking of are all solid core copper. Is there any role for stranded wire?
It's a good question. I'm asked that often. I don't think so. So the difference, there's something called skin effect. And at DC, the complete conductor is being used. And then as we get into AC, where it's going positive, negative, positive, negative. As you get up into very high frequencies, and Tesla discovered this or engineered it, the current starts to travel away from the middle and toward the outside of the conductor. So you have less conductivity. But this happens at extremely high frequencies. We're talking about 60 hertz. It's dead slow. So people say, you know, should I use stranded, use solid? I don't think there's any functional difference whatsoever at 60 hertz. And then if you start talking about higher frequencies of noise, twisting it eliminates that. So I think it's covered. I think the only thing with stranded is it's a little harder to get into the outlets. You can't curl it in a loop around the screw unless you tin it. If you can get it into the clamp plate, it's okay in there. The other thing with stranded, I work with a cable company, and I've been buying their power cables for years. And after a time, I'd get one that wasn't working, and I'd take the shell off and find that it had loosened up and fallen out. And I said, you know, when I tighten up stranded, like I'll go around, I'll tighten the first screw, second screw, third screw, and I get back to the first screw to check it, and it's like, I didn't tighten it enough the first time. You know, but what I think is happening now is, or what I now think is happening is the stranded flows when you clamp it. It flows outward after a time. So I always I let it sit a while and I go back and I proposed this to the cable company and they said, oh, you know what, that's what's happening exactly. So they go do a second tightening and I have
Galbo, sorry to interrupt, but people are clicking on the Zoom on the Amazon link on Zoom and it's a screenshot. So it's not going anywhere. So you have to go to Amazon's website outside of Zoom. And I don't know why people say, click harder, click harder. It's not going to help.
Yeah, that was the joke. I don't think anybody in our group is that stupid. On the other hand, I don't know why Zoom doesn't link directly to Amazon yet. I'm sure that feature is coming.
Oh, okay. I thought you were serious. I'm sorry.
Regarding the stranded wire, I got a comment on that. There's a device that's readily available called a ferrule, F-E-R-U-L-E, I think it, or F-E-R-U-L, something like that.
Yep, yep.
Anyway, what it does, it's basically just a brass tube that fits around the wire. When
Right.
you put it down on the connection, it actually compresses it instead of allowing it to flow out like you described.
Yeah.
The other issue though is that some county codes don't allow stranded wires inside of breaker boxes.
Oh, interesting. The thing with the ferrule, I guess I would argue that it's another connection in the path, which is fine if you apply, you know, one of the pastes to it. But you're right; they're good. They're very secure mechanically.
I'm going to show you guys, you know, two receptacles. The orange one here is the isolated ground. Down by the ground nut here, it has a piece of plastic behind it to isolate it from the receptacle. And this is a different. This one here is a different industrial, you know, grade Hubble receptacle, and it doesn't
Yes,
have
hi.
an isolated ground.
Hey, Gary, can you mute your, the button there?
He's muted now.
Say again, Ronnie. Show us those again, because I couldn't hear.
This is an industrial grade isolated ground Hubble receptacle. It's orange and has a green mark on the front. Now on the back, can you see this little piece of plastic behind the metal? That's what isolates it from ground. This is you know, one that doesn't have the isolated ground. It's also a Hubble industrial receptacle, but it's not isolated ground. It's white. But I've never seen any of the Hubble industrial grade isolated ground receptacles from Hubble that weren't orange.
Yeah, I don't know if I'd like that look, especially if I have 10 of those. I don't think it would look that great.
I liked it when I put in hospital grade because it showed that I was putting in hospital grade. I liked the color.
I use those to let me know which plugs are on my solar system.
There's another thing that I did that Mike Bovair let me know to do, and it's probably not to code, so I'd have to reverse it if we ever if we sell this house. But I put the ground up top because it holds the plug in better that the ground is up top. So
I do that too.
I put it upside down.
Yeah, that's legal, at least in Pasco County. That's fine to code.
And that's a big thing, I think, to hold that ground tight. I think that's a huge thing. You know, what Lynn used to say a long time ago, you know, Lynn is the one who came up with the spikes of leveling the speakers and using spikes first. Lynn came up with that. But Lynn also said, if you want a new system, it said, Ivor Tiefenbrun said, go to each plug and plug it and unplug it, plug it and unplug it like 4 or 5 times, and do that with your interconnects and your speaker cable. He goes, you'll have another system. And I tried that, and it's amazing, just that little thing, how it gets the grunge out, because everything kind of gets used to be attached, you know, and it just kind of breaks up things and cleans things out.
Colin?
So, I'm going to have my whole house rewired next week. But until I do, what's the single most cost-effective improvement I can make to my power and my power conditioning?
The APC. End of story.
I had the APC. Actually, Phil's got my old APC, and I didn't miss it.
This is exactly my point. It depends what your local problem is with the power, and there's a wide spectrum of possibilities. And it's not a question of whether it's a good or a bad conditioner. They're not all inclusive in all the problems that we can have on the power line. And then again, depending on the size of the amp, and again, I joke that you can weigh that in pounds, but it's true, relative to how much insertion loss does this power conditioner have relative to your amplifier. So these are all multiple factors that give you high variable results. And it's just something to be aware of and again, listen for.
Well, Vince, it's not actually a joke. Nelson Pass wrote an article talking about how to determine quality in amps by weighing them. And he talks about the importance of the transformer and the windings and how much they cost. And there's a correlation in solid state amplifiers between the quality and the weight, and therefore the cost.
I didn't know he wrote that, but it's really the same thing as the breaker panel when you think about it. So we want the power supply in the amplifier to have this great unlimited power source, but then within the amplifier, if we've got an audio circuit and it's pulling from the power supply, it's good that that power supply is robust, deep and fast. The way to get that, bigger transformers, more capacitors. You can weigh it by the pound.
Vince, I'd like to make a comment about
Please.
a power conditioner made for a computer like an APC as opposed to a power conditioner made for audio.
Mm-hmm.
And from what I've heard and what sort of directed me away from a UPS or a power supply, a power conditioner made for digital as opposed to analog devices, is I was told that that like the APC or the computer UPSs, that they don't really produce a pure sine wave, and that they actually lop off or clip the tops of the sine wave and give you more of a square wave at a 60 hertz signal. So that the story was that actually analog gear could actually burn out with the wrong power conditioner, and that computers and digital gear is not as sensitive to a square wave, sine wave, sine wave, so to speak, as opposed to a pure rounded sine wave.
Nothing's burned out in 5 years from my APC. Sorry.
Yeah. So anything other than a pure sine wave is likely some cost cutting measure. There's no you can get more power out of a square wave. And then what they do is they rely on when you plug it into, or when you plug something into the APC, the transformer in the power amplifier now is rounding that square wave off because of its load. Mm-hmm. So it's an effort to reduce the cost in the power supply of the APC. It doesn't mean it can't be good. It's just that's why they do that.
Does the amplifier see that as noise, though, a square wave as opposed to a pure sine wave?
Well, it can. My bigger concern is that with an amplifier, and when if the APC is in regen mode, that, then we're talking about the battery and the size of its power supply. And this is, far, for an amplifier at least, this is far from the, unlimited speed and depth of the breaker panel. If your noise and coming from the utility is horrendous, you might find that the APC improves the overall sound. I worry about if it's powerful enough to run, a medium to big amplifier, but, I'll keep saying that, listen to it. And,
well, I guess the question then is, as you brought up that topic, is that battery always in the circuit, or is when it's not in UPS mode, is that battery completely out of the circuit?
See, I don't know that, but I would think.
It's always in the circuit. When the battery goes bad, you got to replace it, or the system doesn't work.
Well, what about, isn't it so that it just passes the power until it sees that there's no power coming in, then it switches to regen mode? That's how I thought they worked.
My understanding is that the battery is always in the circuit, and it's Because when the battery started going bad, I had problems. The system shut down.
I think there are two types of APC home theater conditioner. The one which Jeff got, which is S-Class. It's a little more expensive, and it uses a little bit of battery to generate perfect like sine wave. And you have a cheaper units which have battery completely off the circuit and turn them on only when the power is off.
So it uses the battery to touch up the quality of the power, I think is what you're saying, that's certainly a technical possibility.
And my thing is, you know what, it might sound better, might clean things up, but the problem is if you have your amplifiers hooked into there, I'm always worried about the dynamics because like I said, I've tried it with and without it. And it was almost like another amplifier as far as the dynamics and the effortlessness. Sounds like music, much more like music.
You know, John, when I bought my pass amplifier, I got a 250.5. And when I bought my pass amplifier, I contacted Pass about using a power conditioner or not using it. Now, they're very politically correct over there. So they'll never tell you what to do or what not to do. But they recommended that I don't use a power conditioner. And I have a very old, one of the original power conditioners, the original Tice Signature 3 power conditioner that uses transformers. And they said, well, hook it up to the power conditioner and see what you think, you know? And I was also in discussion with them about power cords because they tell you to use their stock power cord. Well, I did hook it up to the power conditioner and it actually sounds better in the power conditioner. It actually smooths out the amplifier. I mean, it's a very tube-like smooth amplifier to begin with, if you know how pass amplifiers sound, but it actually was smoother sounding and cleaner sounding going through the power conditioner. So
Yeah,
I guess
it could be a per system. I think you have to try it each system.
Absolutely.
That's my point. I say listen to it because you're dealing with so many parameters. You know, again, my feeling is that if you've put in the heavy gauge wire and we've eliminated that as a variable and we've got that improvement, then you're going to be able to hear the difference between power conditioners. And those differences will be, as I said, that's why I talked about that meter. It'd be interesting for everybody to get together and compare their readings day and night and see what their numbers are. Some of you will have good numbers. Some of you might vary the meter. And then the efficacy of the power conditioner that one guy has will say, well, this was a great power conditioner. And somebody else will say, well, it didn't work for me. Well, there's your scale. You'll see why. So,
and you know, I did a comparison on electrical outlets myself, John, and I must have had a dozen of them. And I was comparing each power outlet. And the one I came up with that sounded the best was the Cruise First Maestro. And they don't believe in, you know, plating anything. And I wouldn't really call it a heavy duty outlet, but I compared it to the Hubble and many others. And it sounded the best. It sounded the most analog to me. So I bought those. They're about $90 a piece. And actually that made more of a difference I did also go up to 8 gauge. And I must be running, from my main box, which was on the other side of the wall of my room, there must be maybe a 10-foot span from there to my room. And I ran 8 gauge wire from that. And the Hubble, the Maestro outlets made more of a difference than the actual rewiring of right to the main fuse box. And I actually heard more of a difference with the outlets.
That's interesting. Compared to what outlet?
They put a regular, I forget, I don't know what the name of it is, just a regular outlet that the electrician insisted on putting in his own outlets.
Oh,
He
off the shelf.
Fine. So yeah. He put in the standard outlet, you know, the Home Depot outlet. And then when I changed them, I heard a bigger difference with the outlet.
They grip, you know, your Hubble grip really tight. Now, but let me clear something up on that APC S20. It does not produce its own sine wave unless you lose power. So when you lose power, then it'll make its own sine wave. But up until the time you lose power from a power outage in the house or in the neighborhood, you know, you're using the power company sine wave.
Well, I wasn't accusing APC of doing that. I've just said as a general rule, when
Jeff,
I was looking at power conditioners, the ones made for computers were actually generating a not so good sine wave. I don't know that specific unit.
Jeff seemed to think he was seemed to be under the impression that he's been using his own sine wave from the APC. He has not. He has been using the power company sine wave up until the time he loses power in the house.
But the APC may have, if it's passed through during normal operation, it may have some filtering there, and he's hearing that benefit.
Right.
Is, you know,
correct.
It's not audiophile, but it's a general improvement in reducing high frequency noise.
Vince, I got a question on neutral to ground voltage.
Yes.
Have you measured differences between the runs that you replaced and the runs that were there originally?
Have not, and it's an interesting point because you're trusting your utility that their ground is the same voltage potential as Earth. And it's interesting in England that they don't call it ground, they call it Earth, including the negative on their car batteries. It's Earth. So I'm more interested in the voltage potential between the ground, the ground and the ground from the utility and the neutral are typically tied together in most breaker panels. There is a bonding screw you can remove and keep them separate. But a friend of mine, in fact, he just damaged his 2 Griffin amplifiers, and the power company came out and his neutral back to the utility, which is, you know, their ground at some point in their system. Squirrels had eaten through, and he was down to 2 strands. So he was getting these wild voltage fluctuations, and it took out his 2 monoblocks. And he's been working on them for 3 weeks. But I think what you're asking me is, after this modification, if I measure at an outlet, is there a difference? I haven't done that. You know, I assume with the heavier gauge, whatever the difference was before, it will be less because of the heavier gauge wire, and it has to be a good thing.
Vince, I have a question for you. I have Duke Energy, and they're notorious for fluctuating my voltage. Sometimes I very rarely get anything under 120 volts. And some evenings, if I go to listen, I'm getting 127 volts.
Yes.
And when I find my voltage too high, and I think the threshold is like maybe 124 or 125, my system doesn't sound as good when the voltage is up to 126 or 127 volts.
And it's probably not the voltage difference. Systems are pretty tolerant of that difference, but it's probably whatever's happening on their end to raise the voltage. And this is something that I've known about for a long time. So we've got all the utilities around the country have the ability to interlink. So what's amazing to me is how they keep everything in phase. You know, they lock on. But so Duke Energy is running, you know, so many total amps in their system, and they say, we're starting to run out of power. We're going to get below 120. So they latch on to the next utility in the next county or wherever, and they pull power from them to keep their voltage back up. So when they latch on, it's rather instantaneous. And it could be that utility, its noise is much higher than your utility. In other words, their voltage is falling, but their noise level, if you measure with your meter, will be at a certain level. And then when the noise, it'll just be an interesting test with the meter. When it goes high, you might see more noise. That means that they bought power from another grid that's got, you know, worse noise.
Well, there was one situation where, you know, everybody's house is really getting 240 volts. We think we're getting 120, but we're really not. And what they said, last time I gave them a complaint, they said that one of their transformers blew one leg out. So when they're only running one leg and they're trying to give you 240, they're actually over voltaging that one leg in order to provide the 240 for you. And, you know, the utility wouldn't admit their problem, but the serviceman did admit it when he came to the house and said, oh yeah, when you complained, we found out that we lost one leg. And then we over voltage in order to make sure that everybody's getting the proper 240.
That's
And
interesting.
that was one condition that happened. And they're very, very, you know, as many relay stations as they build, and they probably built 2 or 3 of them in my neighborhood because there's a big expansion taking place here in Central Florida. It doesn't get better. It just stays very erratic.
The air conditioning loads there have to be high. I doubt it wouldn't be like you know, you have like a transformer near your house that runs, you know, 2 or more other houses. And if you lost this one leg of the secondary there, you'd only have half the circuits in your house working. It happened to my daughter, where she said, you know, some rooms got power, some don't. And I went and checked, and one leg was dead. There was nothing. And you may know that it's actually, it's 120 coming in twice, but they're just briefly, it's interesting. If you've got overhead wires, you can see it better, but you've got 3 wires coming in, and let's see, we've got 120 volts, which is, we got our 60, and our 60 adds up to 120. And then we also have on the other wire coming in, we've got the same thing, 120, 120, but you can see they're out of phase. So here we've got, across here we've got 240.
240.
Yeah, so it comes in twice, and it's out of phase. But for what happened to you, if you didn't lose any circuits in your house, that's way upstream at a substation where they lost like their 30,000 volt feed into one of the transformers, so they kicked it up, and yeah, ugly stuff.
Guys, we're coming up on 2 hours here. Do we have any final questions or thoughts, Bart or anybody? This has been fantastic presentation, Vince and everybody, and discussion.
Thank you, Vince.
My pleasure. It's
Thanks,
you know,
Vince.
you're
Great.
quite welcome. Thank you.
Thank you, Vince. I just wish we would have had AJ's interpretation of this. We missed something.
Where's old
He
AJ?
does work for a power company, right? He works for Tampa Power and Light, right?
No,
Yeah.
Hillsborough County or Tampa,
Yeah.
City of Tampa.
No wires, no power makes any difference, you know.
Well, we recorded this. We'll force him to watch it and comment. What we'll do is have a follow-up Zoom session with him to comment on it.
Does he have an
Question
audio
for
system?
Bart, how's your video projector problem going? What are you doing about it?
Oh, nothing. I ordered the 4010 and it'll be here probably Wednesday or Thursday, and there's no problem. I talked with Epson and my distance is fine. And, you know, like I have to have a retractable screen because of my diffusers. So
Right.
That's why I have a projector.
The only thing I can add is there are short throw projectors available. You could have a larger
No,
picture.
I didn't want a short throw. I'm going to be thrilled to death with what I got.
Okay.
I mean, the last one, it's the same screen I had at the last house, and it's like 1 foot closer than it was at the last house.
Gentlemen, I'm going to get back to my family here. I appreciate the interest and the time, and I'd love to hear results for people that have done this modification. It's good to hear that something that's relatively simple is giving such a great degree of improvement. So spread the word.
Right. By the way, did anybody ever tell you you look like the great character actor Harris Yulin?
I know, it's just you.
He's in Ozark on Netflix.
Oh, okay. Poor
Vince,
guy.
thank you so much. Vince, thank you so much. And it looks like you've got a beautiful home up there with what's that? Is that Lake Erie you're looking at?
This is Honey Oil Lake. This is the Third Finger Lake coming from the west, and it's our vacation home. We recently acquired it in February, and then the following month the crisis hit, and it's 3 apartments, so we were able to seal off the units. So my family I got 5 kids and 9 grandchildren, and so there's a lot of people, but we can stay isolated inside, and then we can stay isolated outside. So it's been a great gift for our family, and we're enjoying it.
Enjoy. This was fantastic. Thank you so much.
Yeah, thank you, Vince.
All right, my pleasure to all of you. If you have any further questions, I'm available anytime.
Thank you.
Thank you, Vince.
It was great.
Thank you, Bart, for setting this up. Wonderful.
Yeah, no, thanks for everyone for attending, the great questions, and yeah, we're just fortunate that we have each other to work on and help each other with their systems. And you know, everyone's mileage and tastes are going to vary, and that's okay.
Just listen.
Bingo.
And I set up a specific thread in our discussion forum to follow up on this with further commentary.
Thank you.
Alan, it's good you're recovered from your bicycle accident.
I'll survive. Thanks.
Thank
Stay
you.
well, everybody. Catch you
Be well.
soon.
I'm going to sign off. Thank you all.
See y'all.
Thanks again.
All right. Bye-bye.
Bye-bye.